Hi guys, so today we're going to go over the average rate of change. The average rate of change, you may have seen that word before. Average rate of change represents the slope, the velocity, feet over seconds, meters per second, distance over time. So average rate of change you've seen before in a plethora of ways. So, sorry, my pen is acting up. With the average rate of change, which is just going to be the change in y over the change in x, which is usually in real life scenarios, distance over time, which represents speed. The slope also y2 minus y1 over x sub 2 minus x sub 1. So you have seen this again in a multitude of ways. We're just actually applying it today. So keep in mind, they did give you the interval. So you do have x sub 1 and x sub 2. So we already have the denominator set up. That's going to be 15 minus 2. Now, make sure that you label which one's x sub 1, x sub 2, because notice in the formula it's flipped the other way. And usually the biggest mistake I see is, it's just put in the wrong way when it comes to the order itself. So just a little fun fact. All right, so to find the y value, you guys know the drill. When you replace the x in the function, you will get the y value. So I am also going to notate which one is y sub 1 and y sub 2. So y sub 1, I'm going to replace the x with 2. So this would give me log base 2. Sorry, get a little sloppy sometimes. Equals log base 2 of 2 minus 1 minus 3. PEMDAS comes into play, log base 2 of 1 minus 3. And now, if you do not have a calculator that calculates other than a log base of 10, that's fine. We have our change of base formula. So we will rewrite this as log of 1 over log of 2 minus 3. So we'll plug this into the calculator, and log of 1, if you plug it into the calculator, is going to give you 0. 0 over anything is 0. So we have 0 minus 3, which is just negative 3. So while I still remember that this is y sub 1, I'm going to replace this with negative 3, bring down the minus sign, and from here I'm going to solve for y sub 2. So y sub 2 is when I replace in the x value what x sub 2 was. Guess I'll write it here. Okay, so g of x equals log base 2 of 15 minus 1 minus 3. I'm trying not to kind of make sure these are together, so let me put a little separator there. So this will give me log base 2 of 14 minus 3. Remember, if you have a calculator that will calculate the log base for you, great. But if not, we're going to just use change of base formula, log of 14 over log of 2 minus 3. Today we're going to work on average rate of change. You've seen that word before. Average rate of change just means that it is going to be the slope of the function. Let me just note this here. Average rate of change will be the slope of the function, or the change in the distance over the change in time, which is known as speed or velocity if it has direction. So you've seen this in a multitude of ways. Average rate of change is distance over time, which is also the change in y over the change in x, representing the slope. And this should look familiar. Y2 minus y1 over x sub 2 minus x sub 1. So all these words are interchangeable. You have used this before, and just keep in mind that you do have x sub 1 and x sub 2. So I'm just kind of noting them because notice the order they're written in the formula. Usually the biggest mistake is that it's just written in the wrong order. So I usually just label them for that reason. And x sub 2 would give me 17 minus x sub 1, which is 2. Now, to find y sub 2 and y sub 1, anytime you have the x values for each one, you just replace the x value in the function with that number and you will get the y. So I'm going to start off by finding y sub 1. Notice I'm also labeling it. So g of x equals log base 2. Again, it's y sub 1, so I'm going to take x sub 1 and replace the x with 2 minus 1 minus 3. This will give me log base 2 of 1 minus 3. And again, remember the change of base formula. If you have a calculator that only calculates with a log base of 10, change of base formula, you can rewrite this as log 1 over log 2. And this automatically has a base of 10 if you don't write the base. So you can plug that into the calculator. Log of 1 is 0, 0 over anything, including log of 2 would give you 0, and 0 minus 3 gives me negative 3. So I'm going to replace this y sub 1 with negative 3. I'm also going to bring down the minus sign ahead of time. And then y sub 2. So to find y sub 2, I'm going to take the same function and replace the x with x sub 2, which is 17 minus 1 minus 3. I'm trying to just keep it all in one space, but we'll just take a line there to separate the two. Here you have log base 2 of 16 minus 3. Again, if you have a calculator that only calculates a log base of 10, we'll apply the change of base formula, log of 16 divided by log of 2. And then once we get that answer, minus 3. So log of 16 divided by log of 2 will give you 4. 4 minus 3, that'll give you 1. So from here, I'm going to replace the y sub 2 with 1 and solve. So I have 1 minus negative 3, and minus and negative together makes plus. That will give me 4 over 17 minus 2, which is 15. And that's it. That's my average rate of change. All right, guys, hope this helps.